Okay, Mr. Waterman back again. This is geometry lesson 4.4B, the continuation of hypotenuse leg and side angle side triangle congruence theorems. Now we're going to work with the hypotenuse leg congruence theorem. So, theorem 4.5, hypotenuse leg congruence theorem. First thing you need to know is that this is a special theorem. It only works with right triangles. So the other two theorems we've learned, side, 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 and side angle side, both work with any triangle. This one, gotta remember, only works with right triangles. So the congruence theorem states if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and the leg of a second right triangle, then the two triangles are congruent. So an example here, we have triangle ABC, which is congruent to triangle DEF because they're both right triangles, first of all. This leg is congruent between the two triangles, so AC is congruent to DF. And then finally, the two hypotenuses are congruent. Probably hypotenuse, plural of hypotenuse. So we can say these are congruent by the HL, or hypotenuse leg theorem. So as an example, we're going to take you through a proof. Alright, so in this proof we have a pair of triangles that are drawn back to back. They tell us that YW, this line, is perpendicular to this baseline XZ, and side XY is congruent to ZY. So XY is congruent to ZY. So first step in writing a proof, mark the given on the diagram. So I've marked these as congruent, and we can mark that these two are perpendicular, so I'll indicate that that's a right angle. Alright, YW and XZ are perpendicular. I go ahead and write the given as step 1. So two statements, both givens and the reason. Okay. Next thing we need to do is try and figure out what to do next. We've got a couple things going on. We've got a right triangle, so I think we're going to try and use hypotenuse leg. We also have a pair of congruent hypotenuses. So I'm looking for another side here. We also heard that these were perpendicular. We were given that, but we weren't told that they are right angles. So we have to do something to show that these are both right triangles. So I'm going to go ahead and do that first. So next statement I'm going to write is that angle XWY and angle ZWY are right angles. And that is the definition of perpendicular lines. Right? Next thing, we need to find another pair of sides, so I'm going to use WY, and I'm going to say that it's congruent to itself. It's shared between these two triangles, so I get to use it for each of them. And so I write as WY is congruent to WY, and we write reflexive property. And then finally, it looks like we have the three things that we need. We have two pairs of hypotenuse, so I'll write that out here. We've got the hypotenuse. We have right triangles. Alright, got to have right triangles. And then the third condition is we have a pair of legs that are congruent. This WY is in both triangles. Okay, so we can say triangle XYW is congruent to triangle ZYY.